Hi, this is Mr. Schulke, and I'm demonstrating my popsicle stick catapult, which I built for this project. I chose a catapult because I think launching things is fun. I think launching projectiles is really cool, and exploring some of this technology that's been around for a long time is really fun. And also, I had the materials readily available, so it seemed like an easy choice to choose something for which I already had materials lying around, and it would be a pretty quick and easy build. I thought it would satisfy the requirements of the project pretty well, so that's why I picked this. This catapult demonstrates conversion of potential energy to kinetic energy. Potential energy is stored energy. Anytime you store energy in a system by maybe stretching or compressing something or elevating something so it will respond to gravity, it's the potential for movement to happen, the potential for this thing to move or do work. And so in this case, in this catapult, it stores potential energy in the rubber band. When I stretch the rubber band, it's storing energy, which will be released when I release the catapult. And when I do that, it converts it into kinetic energy, which is the energy of motion. This free body diagram demonstrates the net force acting on the projectile being launched by this catapult. There are a few major forces at play. Because the projectile is flying through the air, it has drag. It's of course being affected by gravity. And then there's the applied force applied by the machine itself, applied by the catapult to transfer energy into the projectile and get it moving. And when adding all those forces together, the sum of all those forces, or the net force, shows that the projectile is going to move in kind of a forward upward motion depending on what angle I release the projectile. In planning how to build my catapult, I actually just did some internet research and found several websites which had good designs and good ideas for building a popsicle stick catapult, including this website here called Little Bins for Little Hands. It has a lot of STEM activities for kids, and it has a tutorial video here on how to build it with certain materials. And I actually built mine a little bit differently, but I did it without drawing any extra plans. So this is the general design that I used, that has popsicle sticks with a popsicle stick fulcrum, all held together with rubber bands. Instead of a bottle cap, I used a spoon to hold the projectile. Looking at my design now, I wish I would have used a bottle cap. As you can see in this accelerated time video, building my catapult was actually pretty simple. It wasn't any harder than putting everything together with the rubber bands. I did pre-glue some of my stacks of popsicle sticks together using just white glue. The materials were very simple: popsicle sticks, rubber bands, a spoon, a bottle cap, and some masking tape. Once I got it all put together, I tested it to make sure that it was going to work and launch. And as you can see, it worked pretty well. I was able to test my catapult launching a large styrofoam ball projectile. And what I did is lined up some tables and lined up multiple meter sticks end to end so I could measure the overall distance that the projectile traveled. Here's a video of me conducting those tests. Over 10 tests, we got a minimum distance of 1.45 meters, a maximum distance of 1.95, and an average distance of 1.75 meters. As you could see with that first launch, getting the direction to be precise enough for it to land on the table was a bit of a challenge. It took me several tries to get it right. I think there are ways to improve the design of the catapult so that it shoots in more of a straight line. And also you can see that it shoots the projectile much higher in the air than I would like it to, and that probably causes it to lose a little bit of distance. So I would change that in the design as well. If I had this project to do over or to redesign a little bit. One thing I would definitely change is the angle of the lever arm at the point at which it releases the projectile. Because I noticed launching, especially a lighter projectile like the styrofoam ball, it launches it very high in the air and gives it kind of a high arcing parabolic trajectory, the shape of a parabola. And I'd want that to be longer to get more distance out of the launch. So a lot more of the energy would go into horizontal motion instead of vertical motion. So I would definitely change that, like you'd see in the diagram, maybe add some spacers or change the angle of the fulcrum somehow so that the spoon is a little closer to perpendicular to the ground when it releases the projectile. I might also make more of a cup to hold the projectile instead of the spoon, because I think the projectile rolled up out of the spoon a little bit during the launch.
I learned a lot from doing this project. I personally learned a lot about structuring a project like this for the students. But from a student's point of view, the things I'd really like to hear are what you learned, what you liked about it, what you didn't like, what skills you learned. For instance, you used any particular tools you hadn't used before, or if you learned things about the design or re-engineering something if you had problems. I'd love to hear about any challenges you had, what gave you the most worry, what was the most fun for you, how does this project compare to other projects you've done before? How does this project compare to normal one-a-day lessons that you're used to in science class? What would you like to see in the future in science class as far as projects that we do? Your feedback is really valuable, and your opportunity to look back on this project and notice what you've learned is the point. So I hope to hear from all of you about things that you actually got out of it.